everyone. Myself, Dr. Ranjith Kumar Gatla, working as an associate professor in Electrical and Electronics Engineering Department. In today's class, we are going to discuss about mesh and super mesh analysis. So here, this mesh analysis is also a kind of network reduction technique. So by applying the mesh analysis, so we can find the current or we can find the response at any element in the circuit. The response either it may be current or the voltage. Okay. So we already know what is mesh or what is loop. So any closed electrical path is called as a loop, and mesh is defined as a loop which does not contain any other loops within it, which are called the mesh. So the difference between the mesh and loop, you just observe. So any closed path is called a loop. Okay. And mesh is defined as a loop which does not contain any other loops within it, which means, so let us consider here, there is a circuit and this circuit having two loops. Okay. So let us consider 1 and 2. So any closed electrical path, which means here this is one loop and this is the second loop, and we can also call it as this is the third loop also. This is also a closed path. Okay, but here, which means here there are three closed loops, but in these three closed loops, how many are meshes? The mesh is defined as the loop which does not contain any other loop within it, which means, but here the loop 3 having the other two loops inside it. So that's why here the loop 3 we cannot call it as a mesh. So here only the two meshes are there. So that is the difference between the loop and mesh. Okay. So if a network has a larger number of voltage sources, then it is better to go for the mesh analysis. And here mainly in the mesh analysis, of course, we already discussed the various basic laws which are Ohm's law and as well as the Kirchhoff's laws. For this mesh analysis, okay, so it is mainly depends on the KVL, okay, which is the Kirchhoff's second law, Kirchhoff's voltage law. So then, and when it is better to use this KVL, the mesh analysis, if the loop contains, okay, if the network contains large number of voltage sources, because if every loop contains single voltage source, then in those cases it is very useful network reduction technique to reduce the network and to find the response at any element. Then what is the procedure to apply the mesh analysis to evaluate the response at any particular element? Okay, so here these are the various steps that we need to follow to apply this mesh analysis. So first we need to identify how many number of loops are there. Then after that we have to give the mesh currents in each mesh, and then after apply the KVL in each loop, then find the unknown mesh currents. Then based on the unknown mesh currents, okay, find the unknown values which we need to find. So let us take one example. Here, this is a simple network. It contains two loops and as well as the two meshes. Okay, so here this simple network having more than one voltage source, V1 and V2. Okay, so then first step is identify the number of loops. How many number of loops are there here? So the number of loops are here. These are the two number of loops, 1 and 2. The next step is give the mesh current directions. So here we should take care about the direction of the mesh currents. Okay, in which direction are based on what criteria we should give the directions of the current in each mesh. So here that will depends on the polarities of the voltage. So here the current the direction is always we usually take high potential to low potential. So which means here plus is the high potential and minus is the low potential. Then the current direction is start from here. Then if it is like this, then it will flow like this. Okay. So starting from here high potential to this low potential. So this is the correction. The direction of the mesh current I1 in the loop 1. Then similarly in the mesh 2, okay, so here the V2 having the polarities like this, so here this is the direction of the current in the loop 2. So let us consider the loop current in the 2 is I2 and I1 is the loop current present in the I1. Then the next step is we should apply the KVL in every loop. So according to the KVL, the algebraic sum of the voltages across any loop is equal to 0. Okay, or the potential difference between the voltage source is equal to, okay, the sum of the individual voltages across the voltage source. Right. So now we are going to apply the KVL, which is Kirchhoff's voltage law, for loop 1 and loop 2. Then the equations. Okay, first let us consider here it is minus V1. Okay, and here it is because the voltage across this is minus V1 and the voltage across R1 is I1 into R1, because what is that, V is equal to I into R. Here the current flowing through R1 we have considered as a I1, and the resistance across this resistor is, let us consider R1. So that's why here it is I1 into R1, and here in this resistor R3 there are two currents flowing. One is I1, another one is I2, because with respect to loop 1 the current I1 is flowing, and with respect to loop 2 the current I2 is flowing. So we should check whether I1 and I2 flowing in the R3 are in the same direction or opposite direction. If the currents flowing through R3 are in the same direction, then we can add. So I1 plus I2 into R3. If the direction of the both currents are various, which means, because here we are writing this equation with respect to loop 1, which means with respect to current I1, so that we should take the reference direction, the reference current direction flowing through the R3 is same as I1. So whether the I2, which is the current flowing through the loop 2, okay, is in the same direction of I1 or opposite direction of I1. Okay, if it is same direction of I1, then we simply write R3 into I1 plus I2. But suppose, let us consider, if the current is in the opposite direction, the I2, then here R3 is equal to I1 minus I2, because I1 is in this direction and I2 is opposite direction. Let us consider if I2 is in opposite direction, because here why not I2 minus I1, why it is I1 minus I2, because here we are writing this equation with respect to the loop current I1, so that's why here we are considering our reference current direction is this one. Okay, but the I2 is flowing a reverse direction of our reference current direction I1. So that's why I1 minus I2. But anyway, in this particular example, in this particular network, okay, so both I1, I2 are flowing in the same direction through R3, because here I1 is in this direction, and as well as here the I2 is also in the same direction. So that's why here R3 is R3 into I1 plus I2. Then next, R2, the current, the voltage across R2 is equal to I2 into R2, and here this, let us consider this is minus V2. Okay, then, okay, of course, again here R3 also, with respect to loop 2 also, the voltage across R3 is equal to I1 plus I2 into R3. Then, with respect to the loop 1, the algebraic sum of the voltage across the loop is equal to 0. So, minus V1 plus I1 into R1 plus I1 plus I2 into R3 equal to 0. This is, let us consider equation number 1. Then with respect to the loop 2, again the algebraic sum of the voltages across the loop 2 is equal to also 0. So then minus V2 plus I2 into R2 plus I1 plus I2 into R3 is equal to 0. So let us consider this is equation number 2. Then if you simplify these 1 and 2 equations, then you will get like this: V1 is equal to I1 into R1 plus R2 plus I2 into R3. And similarly, with respect to loop 2, I1 into R3 plus I2 into R1 plus R3 is equal to V2. So by solving these two equations, we can get the values of I1 and I2. Okay, right? So because by solving these, we can find the unknown mesh currents I1 and I2. Then after that, we can find the unknown value. Suppose if you want to find the current flowing through R1, then R1 means here I1. So I1, what is the, because we have already, calculate the values of I1 and I2 and I3 by using these two equations. Okay. So for better understanding, let us consider the values also, because R1, R2 and R3. Right. So this is the network which is having the voltage V1 is equal to 5 volts and R1 is equal to 2 and R2 is equal to 4 and R3 is equal to 3 and as well as V2 is equal to 10 volts. Now, we are going to apply the mesh analysis to find the mesh currents flowing through each loop. So first step is to identify how many number of loops. Of course, just now we have done which are 2 number of loops are there for this particular network. Then after that, we should give the mesh current directions. So as I told you, this is high potential to low potential. So that's why here I1, the mesh current I1 in the loop 1 is in this particular direction. And again, the mesh current in the I2 loop is in this particular direction. Okay, so which means I1 is in the clockwise direction and I2 is in the anti-clockwise direction. Okay, based on the polarities of the voltage sources present in that particular loop. Then after that, we have to apply the KVL. So further here, let us indicate the voltage across each element. So let us consider this is minus 5 volts and here the voltage across the 2 ohms resistor is I1 into 2 and then the voltage across the 3 ohms resistor is I1 plus I2 into 3 and then the voltage across the 4 ohms resistor is I2 into 4 and here let us consider the potential, the voltage source as a minus. Then write the mesh equations for loop 1 and loop 2. So the algebraic sum of the voltages across the loop is equal to 0. Or in another words, okay, don't get confused why here I have taken the voltage source value as a minus 5. Okay, because as we know, according to the KVL, the potential are the voltage across the source which is equal to, okay, the sum of the potential, the sum of the voltages connected across the source, because let us consider here this is A and B terminal. So across A and B terminal, the voltage source having the voltage 5 and which is equal to what are the other elements which are connected across A and B, because this is 2 ohms resistor and this is the 3 ohms resistor. So which means here let us consider this is V and this is, let us consider here V1 and this is V2, then V is equal to V1 plus V2. Okay, in other words, if you send this V to opposite, the right hand side, then minus V is equal, minus V plus V1 plus V2 is equal to 0. So the same way here we have written the equation, right? Fine. So now this is the equation with respect to the loop 1. Then now the similar way we need to write the equation with respect to the loop 2. So here also similarly minus 10 plus I2 into R4 plus I1 plus I2 into I3. This is the equation. Then simplify this equation. So here I1, 5I1 plus 3I2 is equal to 5. Then 3I1 plus 7I2 is equal to 10. Okay. Then here there are 2 equations and 2 variables are there. We can simply solve these 2 equations to get I1 and I2 values. So here I1 is equal to 0.192 and I2 is equal to 1.346 amperes. So this is the way to find the mesh currents, okay, or the loop currents by using the mesh analysis. Then suppose, in this case, suppose if you want to find the current flowing through the 4 ohms resistor by using the mesh analysis, then what is the current flowing through 4 ohms resistor? Because here the current flowing through 4 ohms is I2. So here the value of I2 is 1.346. So which means here the current flowing through the 4 ohms resistor which is equal to I2 which is equal to 1.346. Similarly, the current flowing through the 2 ohms resistor is I1 which is 0.192. Then what is the current flowing through this 3 ohms resistor? Which is I1 plus I2. So which means here 0.192 plus 1.346, which is the current flowing through 3 ohms resistor. So by using these unknown mesh currents, we can find the unknown values, because before we don't know what is the current flowing through the 2 ohms resistor and what is the current flowing through the 4 ohms resistor and as well as what is the current flowing through the 3 ohms resistor. So by using these mesh currents, we can able to find the current flowing through each element. Right now, okay, let us consider because these are two loops, so very simple. If a network having more than two loops, let us here you can see this is somewhat a complex network when compared to the previous network or previous circuit. So here now we are going to apply the mesh analysis for this particular circuit. So first step is we have to identify how many number of loops. Here there are 4 number of loops are there, 1, 2, 3 and 4. So which means how many mesh currents we will get? 4 mesh currents, I1, I2, I3 and I4. Then next we need to indicate the directions of the mesh currents. Here the direction of the mesh current is very, very important. Okay, if you give the wrong direction of the mesh currents, then you won't get the correct answer. That's why the direction of the currents is very important. So, and it is also very simple to indicate the direction of the currents in a particular loop. That is depends on the voltage source present in that particular loop. Okay, so high potential to low potential. So plus to minus. So we need to start from the plus and finish at minus. Because this is a closed path. Because the current will flow through only the closed loop. Okay, so the current flowing through the open circuit is 0. Right. So then in I1, first let us consider in loop 1. Loop 1 the current direction is like this because high potential to low potential. So plus to minus. Let us consider this is I1. And similarly in the loop 2, again see high potential to low potential. Okay, plus to minus. Right. So which means in I1 and I2 in both the loops the current is in the clockwise direction. And then coming to I3. I3 is also again, what is that? In the loop 3, the direction of the current is from plus to minus. And I4 is also again same, which means in all the loops, the direction of the current is in the clockwise direction, which is based on the polarities of the voltage source. Now, we need to apply the KVL. So, for that, we need to write the voltage equation at each element. The voltage equation at each element. So here usually first let us consider here the first loop. Okay, let us consider this is 10 volts. Okay, and then here it is the current flowing through loop 1 is I1 into 2 ohms. And but here as you can see I1 minus I2 into 1 because here I1 is in this direction and I2 is the opposite direction to the reference current direction. So that's why, because in the previous example it was I1 plus I2 because I1 and I2 are in the same direction. But here, the current flowing through the I1 with respect to loop 1 is in this way, okay, the downward direction. But with respect to loop 2, the current flowing through the 1 ohm resistor is opposite direction to the I1. So that's why here, the voltage across the 1 ohm resistor with respect to loop 1 is I1 minus I2 into 1. I1 minus I2 into 1. Then similarly, coming to the loop 2. Okay, of course, one more resistor is there here, 1 ohm resistor. So, here I1 minus I3 because I1 is in this direction and I3 is in this direction. So, again both are opposite direction but our reference direction is I1. So, that's why we have taken positive sign for the I1 and negative sign for the I3. So, I1 minus I3. Then coming to the loop 2. Again, okay, let us consider this is the 10 volts. Okay, and then here the current flowing through the 1 ohm resistor is I1 minus I4 into 1 because I2 minus I4 because the current flowing through the loop 2 is I2 and the current flowing through the loop 4 is I4 but here the reference direction is I2 so that's why I2 minus I4 into 1. Then similarly, the current flowing through 1 ohm resistor with respect to loop 2 or with respect to current I2. So that's why here I2 minus I1 because here the reference current direction is I2. So but here I1 is opposite to I2. So that's why here I2 minus I1. But in the loop 1 it is I1 minus I2 because here the reference current direction is I1. So don't get confused, right? Here it is I1 minus I2 and here it is I2 minus I1. Then similarly here the current flowing through, the voltage across the 2 ohms resistor is I2 into 2. Then similar way we can also write for the loop 3. Okay, and the loop 4 also, and here I4 minus I3 and here I4 minus I2 into 1. Now we have written the voltage across each element. Now we are going to apply the KVL for each loop. Okay. So in the first loop, let us consider here minus 10 plus I1 into 2 plus I1 minus I2 into 1 plus I1 minus I3 into 1 is equal to 0. This is the equation with respect to loop 1. Similarly, the equation with respect to loop 2, which is again minus 10, because the same way, okay, we will start from here, okay. So then, first here it is 10 and then 1 ohm. The voltage across the 1 ohm resistor is I2 minus I4 into 1, and then we will go for here, then here again 1 ohm resistor. So here I2 minus I1 into 1, so I2 minus I1 into 1, and then again we will go for this resistor, then I2 into 2 is equal to 0. Then say same way loop 3, okay, we will start from here again. So 10, and here the voltage across 1 ohm resistor is I3 minus I1 into 1, and then the voltage across the 1 ohm resistor, here it is I3 minus I4 into 1, then here the voltage across this 2 ohm resistor is I3 into 2 is equal to 0. The same way in the loop 4 also, we will start from 10, okay. So here first we will write the voltage across I4, which is I4 into 2, and then the voltage across 1 ohm, this is which is I4 minus I3 into 1, then similarly this is I4 minus I2 into 1 equal to 0. Then by solving these four, of course, next let us simplify these equations, okay. So by simplifying the first equation, we will get I4I1 minus I2 minus I3 equal to 10, and similarly for the second equation and third equation and fourth equation. So here you will be having 4 variables I1, I2, I3, I4 and 4 equations. So solve these 4 equations, then you will get the values of I1, I2, I3 and I4. Okay. Then after solving these 4 equations, the values of the currents I1, I2, I3 are 5 amperes, 5 amperes and 5 amperes. Okay. So coincidentally here all the currents flowing through the all the loop currents are same. I1 is equal to 5, I2 is equal to 5, I3 is equal to 5, I4 is equal to also 5 amperes. Okay. So which means here, suppose let us find the current flowing through each 1 ohm resistor, because how many 1 ohm resistors are there? 1, 2, 3 and 4. Okay. Because here the current flowing through 1 ohm resistor is I1 minus I2 into 1 or I2 minus I1 into 1. Okay. Suppose if it is I1 minus I2 into 1, if you consider, then the direction of the current is same like the I1 you have to consider. Or if you want to use the equation I2 minus I1 into 1, then you have to consider the direction of the current flowing through the 1 ohm resistor is like I2. Okay, so that is based on, because of course the value you will get the same, but only the direction is different, that's all, plus or minus. So here anyway, the currents flowing through each loop is equal to, is the same currents, so that's why then the current flowing through the 1 ohm resistor is also 0, because 5 minus 5, because here it is I1 minus I2, and here it is I2 minus I4, and here it is I3 minus I1, and here it is I4 minus I2. So which is equal to 0, because all the currents are 5 amperes and 5 amperes. So 5 minus 5 is 0. So or suppose even what is the current flowing through this 2 ohms resistor? I1. So I1 is 5 amperes. So here it is 5 amperes, and again here it is 5 amperes. Okay, here also 5 amperes and here also 5 amperes. Like this you can find the current flowing through any resistor after finding the loop currents. So this is how we can use the mesh analysis to find the unknown values or the unknown voltage or unknown current, okay, at any particular resistor. Suppose if you want to find, okay, so what is the voltage across these 2 ohms resistor? Okay, so here V is equal to I into R. So here I is, what is I is here I2 is equal to 5 into 2, so which is 10 volts. Then the voltage across the 2 ohms resistor is 10 volts. Like this we can find. Or if you want to find the voltage across this 1 ohm, okay, is 0, because why it is 0? Because here, as you can see here, because the current flowing through 1 ohm is 0, so that's why 0 into 1 equal to 0. So which means the whatever the potential, whatever the voltage here it is, the total voltages appear across these 2 ohms. So that's why here the voltage across this 1 ohm and 1 ohm is 0. So that's why here 10 is equal to 10 again. Hence the KVL is proved. Fine. So I hope everybody get understood about the mesh analysis. Then, of course, just now we have considered the circuits which are having only the voltage sources. Suppose if the circuit having the current sources, then how we can apply the mesh analysis? Of course, the same procedure. First, we need to just identify how many loops are there, because here this is one loop and second loop, okay, and this is the third loop. Let us consider. Then again, we need to indicate the direction of the currents in the loops. Okay. Of course, anyway, here in the loop 1 already they have given the direction of the current. Here this is, because in the current source, this is the arrow mark indicates the direction of the current. So that's why we should take the same direction. And even in the loop 2 also, here 8 amperes current source is there, and here also arrow mark represents the direction of the current. So we should take same way. And when coming to the loop 3, anyway, after going this way, okay, so this way, then the current will divide here and here. Okay, so that's why we are just taking the direction of the current in the loop 3 is in this way. Now, it is very easy if they give the current sources instead of voltage sources, because here directly we know what is I1. Okay, the current flowing through this loop is 3 amperes that they have already given, and the current flowing through this second loop is 8 amperes they have already given. Okay, so we no need to again write the the mesh equations, okay, to find the current I1 and I2, because directly they have given the I1, the current source 3 amperes, which means here the current flowing through this loop is 3 amperes and the current flowing through the second loop is 8 amperes. But what about the current flowing through this third loop, I3? For that, we need to write the equation. Okay, so what is the equation? How we can write? Okay, let us start from 1. Okay, so I mean, how to get this equation? So 1 into I3 plus here 2 into here I3 is the reference direction, so I3 is in this direction, and I2 is also in the same direction, so I3 plus I2 plus here at 5, okay, the voltage across the 5 ohms resistor. So 5 again here it is in this direction, but here it is in the opposite direction. So which means I3 minus I1. So 5 into I3 minus I1, which is equal to 0. So here what are the I1 terms are there? Here 5 into I1 is there, so minus 5 I1. And what are the I2 terms? Here 1 I2 term here it is there. Okay, that is 2 into I2, so plus 2 into I2. And what are the I3 terms? Here 5 I3. Okay, and here 2 I3, so 8 I3 equal to 0. Then substitute the I1 value and I2 values in this equation, then you will get I3, because I1 you know what is the I1 value, so minus 5 into I1 is here 3 amperes plus 2 into I2 is 8 amperes plus 8 I3 equal to 0, then you will get the I3 value is 0.125 amperes. So very simple, right? In this way, we can find the unknown current, the unknown loops current, because the loop 3 we don't know. Loop 1, loop 2 directly they are having the current sources, so we can get directly the loop 1, I mean the current flowing through the loop 1 and loop 2. But loop 3 current is in this way we can find. Then let us consider another example. So here, as you can see, there are 3 loops are there. Okay, 1, 2 and 3. Then in these 3 loops, the current directions, as you can see, of course, suppose in the loop 1, let us consider the current direction is based on the polarities. Okay, high polarity to low polarity is fine. But I2 is also, let us consider here the current source is there. So we are just considering the same as the current source direction. Okay, but in loop 3, okay, again based on the voltage source we can find. But here as you can see, this current source is in between loop 1 and loop 2. Okay, in between loop 1 and loop 2. So then how it in this particular cases it is very difficult to apply a simple mesh analysis. Okay. Then in this case, what we have to do? So in this case, we will go for a technique called super mesh analysis. So which means when we will go for the super mesh analysis, if there is a current source in between the two loops, then we will go for the super mesh analysis. That's what here. Suppose any branch in the network has a current source, and then it is slightly difficult to apply the mesh analysis. Then this difficulty can be overcome by using the super mesh analysis technique or super mesh technique. So this super mesh is constituted by two adjacent loops that having a common current source, because in the previous network you can see here the two adjacent loops having one common current source. So in these cases we are going to apply the super mesh analysis. Then how we are going to apply the super mesh analysis? Here you can see. Of course, the procedure is same again. First we need to identify the number of loops, then again we need to give the loop current direction and then apply the KVL, and after that we need to find the unknown mesh currents. So based on that we can find the unknown values. Right. So here first let us consider a simple network, because here also as you can see there are two loops, loop 1 and loop 2, and in between the adjacent loops, loop 1 and loop 2, there is a current source. So which means here we cannot apply a simple mesh analysis. So we need to apply a super mesh analysis. So how we can apply the super mesh analysis? Here we will see. So first, same way, loop 1 and loop 2. Okay. And apply the KVL V1. Okay. Here in, the voltage across R1 is I1 into R1 and the voltage across R2 is I2 into R2 and V2. Okay. This is again the same procedure like the previous in the mesh analysis. But here we should consider a super mesh. Okay. So we should consider a super mesh. So first we should write mesh analysis, because here as you know the current flowing through this here it is I. But what is I here? The current flowing through the loop 1 plus the current flowing through the loop 2. Okay. Again it is based on the direction again. Okay. Because here the direction of the loop current I1 and I2 we have considered based on the polarities of V1 and V2. But here as you can see here the I1 direction and I2 direction both are same. So that's why I is equal to I1 plus I2. So we get one equation. And the second equation, okay, then we may get doubt, okay, which loop we need to consider, whether it is 1 or 2. So we should not consider 1 or 2. We should consider the another loop which is third, that is the super mesh. Okay, so the third loop is just neglect this one and consider the loop which is indicated with the red dotted line. So which means now apply the KVL for this particular loop. So which means here minus V1 plus I1 into R1 plus I2 into R2 minus V2. Okay, so of course here, here again it is based on the direction of the current. So here whether the super mesh loop or the super mesh or super mesh current direction and the actual mesh current are same or not, that is also important. So here as you can see here the super mesh current direction is like this, and here the loop current direction of the I1 is also same. So that's why here we are taking the basic way, that is minus V1 plus I1 into R1. But when coming to the second loop, okay, here the actually loop 2 current is in this way, but the loop the super mesh current here we are considering in this way, so opposite direction. So that's why we should make it as a because opposite direction means the opposite polarity. So that's why minus I2 into R2 minus of minus V2 is plus V2 is equal to 0. Right. So now simplify this equation. Then by solving these two equations, then we can get I1 and I2. So okay, let us consider some values. Okay, for these two. Yes, let us consider here the V1 is 5 volts and R1 is 2 and R2 is equal to 3, and here the current I is 4 amperes and V2 is equal to 10 amperes. Then again two loops are there. Okay, and the two loop current directions are also we have given the similar way, right? Then here I is equal to I1 plus I2, which means I1 plus I2 is equal to 4. Okay. Then here we are writing the equations, the voltage equations set across each element. Okay. So I1 into 2, I2 into 3 and minus 10. Then now we are indicating the super mesh. And now we are writing the equation for the these I1 plus I2 is equal to 4 and as well as the super mesh. So if you simplify these two, then you will get I1 is equal to 1.4 and I2 is equal to 2.6. Okay, because again, it should satisfy this equation. So 1.4 plus 2.6 is equal to 4 amperes again. So this is the way to apply the mesh analysis. Of course, this is very simple network, but let us consider some more, complex network which is having 3 loops, basically. Right? So in this case, then how we can find? Here actually what they are asking to find, what is the current flowing through the 3 ohms resistor. Here, what is the current flowing through 3 ohms resistor by applying the mesh analysis. Anyway, of course, in your examination, they didn't mention whether you need to apply mesh or super mesh analysis. Okay, we need to identify, okay, whether we need to apply a simple mesh analysis or is there any requirement to apply the super mesh analysis. Okay, so because here, of course, there is a 5 amperes current source is there in between the 2 adjacent loops. So which means here we should apply a super mesh analysis that we can identify. Then now again, just let us indicate how many loops are there. There are 3 loops are there. And again, we are giving the directions of the loops. Okay. So here the direction of the loop current in the loop 1 is based on the voltage source polarities. And in the second loop, we are just considering, based on this current source having in the loop 2. And again, in the loop 3 based on the voltage source polarities. Right. So, of course, here again, one equation is with respect to this current source, which is, of course, here as you can see, the current direction is in these 5 amperes is opposite, because in loop 1, I1 is in the downward direction and I2 is in the upward direction. So that's why in this case, let us write the equation is I2 minus I1 is equal to 5, because here the direction of the actual direction of the current source is in this way. So that's why we are taking I2 as a reference. So but I1 is opposite direction. So that's why I2 minus I1 is equal to 5 amperes is the first equation. Then the second equation is with respect to super loop. Okay. So which means here again, of course, in this case, as you can see, the I1 current direction and I2 current direction is same as your super loop current direction. So that's why here you no need to consider the minus sign as like in the previous example. So here simply minus 60 plus I1 into 5 plus I2 into 2 plus I2 plus I3 into 6 is equal to 0. Then the third equation is with respect to loop 3. Okay. The third equation is with respect to loop 3. With respect to loop 3, again minus 50 plus I3 into 3 plus I2. Of course, here also this current direction and this current direction are same. So that's why here I2 plus I3 into 6 is equal to 0. Then after simplifying these 3 equations, then you will get I2 minus I1 is equal to 5 and 5I1 plus 8I2 plus 6I3 is equal to 0 and 6I2 plus 9I3 is equal to 0. Then by solving these 3 equations, then you can find I1, I2 and I3 values. So here the I1, I2 and I3 values are I1 is equal to 0.74 amperes and I2 is equal to 5.74 amperes and I3 is equal to 1.72 amperes. Then now what is according to the question, we need to find the current flowing through the branch AB, which is the current flowing through the 3 ohms resistor. The current flowing through 3 ohms resistor is I3 here. So I3 is equal to 1.72. Then the current flowing through this 3 ohms resistor is from B to A, the direction, which is 1.72 amperes. Okay, IAB is equal to 1.72 amperes. So this is the way we can find, because this is unknown value that we are going to find by using this mesh analysis. Of course, because here in between 2 loops, 2 adjacent loops, there is a current source. So that's why here we gone through the super mesh analysis. So I hope everybody is clear about when we need to apply the mesh analysis and what is the procedure to apply the mesh analysis. And especially in the mesh analysis, it is very important to indicate the right direction of the loop current, and the right direction of the loop current is depends on the polarities of the voltage source. So high potential to low potential, right? Then when we need the super mesh analysis and how we can apply the super mesh analysis, these things, okay, we learn from this class. So I hope everybody get understood. Okay, thank you. In the next class, we will discuss the nodal analysis.
Like, share and subscribe. Hit the bell icon for more updates.